you, how can you make money out of this area at the moment? It's very difficult. So
you could get a grant like D-Wave.
Yeah.
Patents?
Yeah. Yeah. I mean,
yeah, but patents are valid for 20
you need
years.
to pay for the patents, yeah.
But if these things are going to be available on desktops in 10 years' time, you would expect some far-sighted investors to be backing this stuff now.
I mean, the kind of funding you need to set up systems to do this research it's millions, which is not very much on the scale of governmental budgets, but on the scale of individual venture capitalists and companies that don't know if they're going to make any money for 5 to 10 years is quite a lot to invest. It's quite a lot of risk. So
maybe it's too early for the commercialisation. Maybe it's just going to continue in there.
I think it will continue in research. I think people like D-Wave are very, they're taking a big risk, but there will be an enormous payoff if it does work. So again, this is just like saying the same thing. How far away is the technology? We've only, I mean, 20 years ago, people were saying we'll have these systems in 5 years. So what can you say? We still only have very small systems at the moment. But I think within 5 to 10 years, at the current level of funding, and hopefully with some accelerated funding and breakthroughs, we'll be able to improve on that. And I think it will get easier as we demonstrate more and more systems working, more and more results. And like I said earlier, there might be some previously unconsidered applications discovered along the way. So I think as the final slide, I just put this up. So why should the H+ community care about this? I think it's mainly if you look at kind of like Epoch 5 in Kurzweil's book, it talks about the merging of technology and human intelligence. And I think at this point we are going to actually have to answer some of the sticky questions about, I mean, things like whole brain emulation and stuff like this. So I think this might come into play. And it also has lots of potential applications in...
so for the people who are not so familiar with this, can you just
sorry,
say a little bit more about
this is the idea of there being the evolution of human knowledge and human intelligence, and it comes in stages, and in each stage there is kind of like a built-in S-curve. So you have a rapid rate of progress which then tails off, but instead of it just tailing off and not continuing, you then have another breakthrough. So here we've got, the first one was physics and chemistry, and the second one was biology, and then, I can't actually read that.
These are not like the human fields of physics and chemistry, but early universe development.
Yes, this is actually understanding the laws behind what governs these things. So the law, I think the laws of physics, understanding how physics works, and then biology, and then brains, which
I think it's the emergence of brains. So the universe spent a long time in which there was nothing more interesting than physics.
Yes.
And then on various planets there was the emergence of biology.
I see.
And then
you have brains, and then technology. And then this one is the merging of technology with human intelligence. And then the last one is the kind of universe becoming conscious and waking up, like that. So I think this can actually help us with number 5, maybe number 4 as well. And these are, again, I've just put the areas which it can help us, and it can hopefully answer some of these important questions about metaphysics and consciousness along the way. So I think that's the end of the talk.
So we'll give you a round of applause. Yeah.